Okay, so in this video, we are going to go over the concept of a parent function. So I like to think of parent functions as kind of just like the largest category. And then within that, you have all of these different types. So a good way to relate that to the real world would be, let's just say like dog breeds, right? So this is kind of the major category. And then these are all the subcategories, right? So this would be like labs. This would be golden retrievers, right? And so on and so forth. And so what will happen is if you were just having a conversation with me and you said you had, a golden retriever at home, that would tell me, generally what you're talking about, right? Because I know some just broad general properties of golden retrievers, right? I know that they're typically golden color. I know that they're typically larger, right? Anywhere from, I don't know, let's say like 70 to 90 pounds. And so I can really have some information without knowing the specifics. So that's exactly why this is valuable for math, right? If I gave you a function like, let's just say, 3x minus 5 squared plus 7, right? Because I know that this parent function is x squared, I know a lot about that function without actually having to graph it. So that's kind of the goal here, is to just give you enough information, especially on a multiple choice test, to really narrow down your answer choices, even if you don't know every single thing that you would know by graphing it. And actually, you basically will know as much as we go through these videos. You can basically, I'll teach you how to graph this in your head. But anyways, but just to give you a general overview. Okay, so let's dive in. In this one, we're only going to go over the constant function. And then in the next videos, we'll go over some of our other parent functions. So let's talk about this constant function. So you can see the rule here. It's just f of x or y equals c. And let's take one quick step back and let's talk about this notation. F of x is the same thing as writing y. So these are both outputs, right? So going back to our concept, and it's just two different ways of writing the same thing, but going back to our concept of taking something in and giving something out, that's what this notation means. So f is arbitrary. We could have a function that was called h of x, or we could have a function that was called g of x. So in the real world, we're going to name our function based on what makes sense. So we could have a profit function, right? So if I was modeling profit, I would do p of x, right? Or I could have a cost function, so I would use c of x. So anyway, so don't get confused by that notation. F is just the most common because it stands for function, right? So f of x is just the function of x, which brings me to my next point, which is how we identify the input, right? You'll see in parentheses here, we have this x. That tells me that this function is taking in x values. That's the input, and it's going to give us out y values. So let's talk about what that actually means in terms of this example. So with a constant function, it's always going to be a horizontal line like this. And that is really because if I just label these axes, right, x and y, no matter what x value I put in, it's always giving me out the same y value. Let's say that it crosses through at 1 there, right? So no matter if I were to do an xy table for this function, if I put in negative 100, what would I get out? I would get 1. If I put in negative 10, I would get 1. If I put in 0, I would get 1. If I put in positive 10, I would get 1. And I think you get the point from there. So that's why it's called this constant function, because you're always getting out just a number from that function. So now let's talk about the domain and range. The domain is what I can put into the function, right? And I kind of think about domain in multiple ways. One way is I kind of just look for arrows going right and left, right? So look, it's going on forever to the right and forever to the left, right? There's no clear end point. Like if we look at the square root function, right, we have this end point here, right? We don't have that. It's going on forever in both directions. We also don't have any asymptotes, right? And we'll go over that in more detail later, but an asymptote looks like this dotted line, right? We don't have any of that. We just have this function that's going on forever in both directions. So that tells me that the domain is going to be all real numbers. So basically just meaning anything, right? We can put in negative 100, I can put in positive 100, right? There's no restrictions. So now let's talk about the output, right? Or the range. So the range of this function is interesting, right? And that's going to be my y values, right? My y value is always only going to be 1. So the range of this would literally just be 1, because no matter what I put in, I'm always getting 1 out. Okay, so hopefully that makes sense for now. Let's call it here for this video, and I will come back and we will talk about a few more of the parent functions. Thanks for watching.